Let's go to chapter 10. So these are the 5 sections remaining. Let's work on 10.1 and 10.2 today. Okay, I put some videos here. If you want to watch later, for now, let's go to the PowerPoint. And then we'll do some problems together. So I go briefly over the PowerPoint. And then we'll do problems together. Okay. The 2 things that we're going to work on will be correlation and regression. So these are the 2 main things that we are doing today. Oops. Okay. We introduced the linear correlation coefficient R. If you remember from a few weeks back, I gave you a calculator command to find linear correlation coefficient R. So today we're going to talk about testing around that. So linear, just remember linear relationship. Linear relationship is testing the strength of the line, the strength of the correlation. So if you remember from earlier, then that's between -1 to 1. If it's +1, it's a very strong positive correlation. -1, very strong negative correlation. And if R is 0, it's no correlation. So basically very strong, and if R is 0, no correlation. Okay. So now let's go to the next page. Correlation. A correlation exists between 2 variables when the value of one variable is somehow associated with the values of the other variable. Please write this definition. Basically, that's the main idea of correlation. Okay, linear correlation exists between 2 variables when there is a correlation and the plotted points of paired data have a pattern of a straight line. So also pay attention to this one. So the pattern should be a straight line, and then linear correlation exists between 2 variables when there is a correlation, and that forms a string line. So when you have dots and then the dots have a pattern of a linear correlation. So this is a positive correlation. If you remember from a little bit earlier, we said as we move from left to right, if our graph is going up, then it's a positive correlation. If it's going down, it's a negative correlation. The closer the number to 1 or -1, the stronger it is. So do you see this is 0.85? It's pretty close to 1. So as you see, it has a nice correlation. And then this one is a negative correlation. And it's stronger than the previous one because it's even closer now to -1. So the closer to 1 or -1, the closer to strong correlation. If you remember this examples we had with positive and negative correlation, we talked about serial and customer satisfactions or customers rating. And then the more sugar, probably the less favorite of customers, the more fiber, the better rating. So fiber is a positive correlation because the higher the fiber, the higher the rating of customers or satisfaction. Sugar is a negative correlation because the more sugar, the less satisfaction or customers usage or rating. And this one is no correlation. Do you see? You cannot think of any strong line. And then as you see, this is pretty close to 0. If it's not a linear pattern, then don't use R. I mean, if it's not even forming a line, as you see here, it's forming a curve. Okay. Linear correlation coefficient R. So we find the measurement of R showing the strength of the relationship, and we're going to use our calculator for that. Okay, let's determine if there is a linear correlation between two variables. So we are not using much of these notations except n is the number of pairs of samples. So we're going to do a testing here. We're going to test if there is correlation or there is not a correlation.
Excuse me, Professor.
Yes?
Could you go back to the linear coefficient R slide right quick, please?
This one?
Yeah, thank you.
Okay, now we want to test to see if there is a correlation or not. So I skip to, okay, let's just look at these notations. We're going to use these. R linear correlation coefficient for sample data. Rho, we call this rho. Linear correlation coefficient for population of paired data. So we're gonna, when we are writing the test, so null hypothesis and alternative hypothesis, we would say null hypothesis is when there is no correlation for the population. And then alternative is when there is a correlation for population. So the way we show it is we say rho equal to 0 means there is no correlation. Rho is not 0 means there is a correlation. So please copy that. No correlation for population, so it means rho is 0. If you remember, we said if R is 0, there is no correlation. R1, R negative 1, very strong correlations. So correlation for population, rho is not 0. So rho equal to 0, rho is not equal to 0. Okay. So we're going to practice that. Okay. So please make sure that if you are using this testing, it must be simple random sample. Plot the points and make sure the visual examination passing a straight line. So far, two things. Simple random sample. When you plot the points, it's forming a line. And if there are outliers, they must be removed. Outliers are really making a difference. So simple random samples, visual examination that it's a straight line, and then outliers should be removed. Okay, the rule of rounding is to round to 3 decimal places for R. So exactly like before, if p-value is less than alpha, we support the claim, and we said null hypothesis is rho equal to 0 means no correlation. An alternative hypothesis is rho not equal to 0, and that means correlation. So if p-value is smaller than alpha, we support the alternative, which is there is a correlation. If p is a large number, we do not support the claim that there is a correlation. So exactly like if it's a positive correlation, then we're going to use greater than 0. If it's a negative correlation, we put less than 0. Exactly like before, you could have any of the 4. But if it's just correlation or not, then rho equal to 0 is no correlation, which is always the null hypothesis. And then rho not equal to 0, greater than 0, less than 0, is when there is correlation, positive, negative, or just correlation. Any questions so far? Okay. So you don't need to have the critical values to judge, just have these in mind. The values of R is always between -1 to 1. Inclusive means negative, could be -1, could be +1 when it's a perfect line. Points are exactly on a perfect line. Okay. So before we go to technology, I want to just know if you have an idea of correlation coefficient. Let's just add a page here. Okay. So I'm gonna tell you that, let's say I'm gonna create R. Let's say we have R equal to 0.9. I'm gonna create two windows. Tell me which one is R equal to 9.9. Sorry, I don't mean to put the lines. My pen is acting up. So send me chats, A or B, which of these point sets or set of these pairs have R of 0.9? A or B? Great job. Please send it to me individually so I can. Excellent. So you choose B because you see it's positive and is strong. So what is about A? Negative correlation or positive correlation for A? So please also chat that with me. A is a positive correlation or negative correlation? Okay, excellent. Mazen, look at A. The graph is going down as you move from left to right, so that's a negative correlation. Okay, thank you everyone. So this one is the answer in this case. This is a negative correlation. This is a positive correlation. Okay. So let's go here. Let's do an example. Let's do it from our textbook, actually. We may find nicer examples from the textbook. I want all of you to pull the textbook up. Let's go to the e-text. Let's go to chapter 10:1. Just look at this definition. When we find r squared is the explained. So r squared is explained variation. So do you remember variance? So r is the coefficient, correlation coefficient, and r squared is explained variation. Formal hypothesis testing, we're going to do that right now. Null hypothesis is always equality, but equal to 0. That means there is no correlation, because when r is 0, and for population, when rho is 0, means there is no correlation. Not equal to 0 means there is a correlation. If this was greater than 0, means positive correlation. Less than 0 means negative correlation. Okay. So here are the calculator command that we will be using. Okay. Okay, let's work on problem number 14. Old Faithful. May I have a volunteer to read number 14? And that's
I
page
can read.
400. Yeah, go ahead, please. 408. Go ahead.
Listed below are duration times seconds and time intervals minutes to the next eruption for randomly selected eruptions of the Old Faithful. I don't know how to read this.
Geyser.
Geyser in Yellowstone National Park. Is there sufficient evidence to conclude that there is a linear correlation between duration times and interval after times?
Thank you. So these geysers in Yellowstone, I don't know if you've been there or have seen geyser in the past. There is a duration for the geyser, and then the interval after, no one exactly knows how many seconds later or how many minutes later the geyser will start again, but they know about the time. So they want to know if the geyser goes for longer. They specifically observed Old Faithful. They want to know if the geyser goes longer, does that mean a longer interval after until the next geyser? So that's what they are testing. Is there any correlation between duration and time after? So we start with null hypothesis, alternative hypothesis. So null is rho equal to 0, means no correlation. And then alternative is rho not equal to 0, means there is a correlation. Okay, so let's now start with putting that in our calculator. So I want you to follow the steps with me. So let's go to your calculator. Grab your calculator, and someone needs to read me the numbers. If you don't mind, take a picture of this page. we need to take a picture here, and then we're gonna enter it in our calculator. Okay, what are you expecting to do first without even going through any testing yet? When you have sets of data, what do? What's the first thing that comes to your mind?
You plug
Put
it
it
into
into L1 and L2.
Excellent. To those who responded, you put them in L1 and L2. So let's just go and do that. So let's go to our calculator, clear. Okay, let's go to stat, edit, L1. So can someone read L1 to me, please? Andrew, do you have the numbers in front of you if you don't mind to read them off?
Yeah, I'm pulling up a little bit. I lost the page.
I see. Anyone else? Mala, do you have the numbers?
Yeah, I do.
Okay, go ahead, please.
So 242,
42,
255,
255,
227,
mm-hmm,
251,
mm-hmm.
262, 207, 140.
140,
Mm-hmm.
okay. And then L2,
L2 is 91,
uh-huh,
81, 91, 92, 102, 94, and 91.
okay, thank you. So now you have the data in L1 and L2. You go to stat, you go to test. If you remember earlier in the semester, we used line regression. Now go to test and find the linear regression t-test. Before that, I like to look at the graphing with you. So we're gonna use the testing here. So see that the things are in L1 and L2, and rho is not equal to 0. So that's what you need to pick. And then you go ahead and calculate, which is gonna give you A and B and P and so forth. But let's go to graphing. I want you to follow the steps I'm asking you. So you have items in L1 and L2. Let's just leave it for now. And then let's graph those data because we said visual linear examination is important. So do you see second and then y equal to? Second, y equal to, and the key history is at the bottom here. Second, y equal to. You're gonna make the plot on. So you click, enter, and then click again, enter twice. It's already on a scatter plot. Do you see the graph is already on the scatter plot? You leave it there. X is in L1, Y is in L2, and then it says, how do you like the points to be shown? With dots, with this, with that, what color? So that's the part you put the plot on. Then you go to zoom, and let's say zoom stat. Pick zoom stat. Do you see a very strong correlation here? It doesn't seem to be a very strong correlation. Whatever you do around the points is not a strong. So visual examination doesn't show any curve pattern. It shows linear, but it seems to not be very strong. So I like you to examine this. Now let's go and test it. So let's go down. Linear regression test. So not equality. R should be a very small r close to 0 because there was not a good correlation. So as you see, R is 0.004. This is not as strong. Because it's close to 0. Okay, if I'm writing equation of a line, y equal to, if I was writing a best line that fits that graph, it says a plus bx. A, it's 90.19 plus b times x, 0.0067 x. So that's the equation of the line. So if I write it meter, so it's y equal to a 90.19 plus b times x, 0.0067x. That's the line of best fit. Line of best fit. Using this one, I can say like, oh, if the duration is 105 seconds, what would be the interval of waiting? You plug in X and you find Y, or vice versa. So that gives you the prediction. We normally show it with Y hat. Okay, and then let's just look at the p-value. Okay, and p-value is following. You have a large p-value. It's definitely greater than 5%. So if we have large p-value, do we reject a null or we fail to reject a null? We fail to reject a null and do not support alt. So fail to reject a null and do not support alt. So then you would say there is not enough evidence to support the correlation between duration and time interval in Fateful and Yellowstone. There isn't enough evidence to support that there is a correlation. If this was a small p, then you would say there is enough evidence to support that there is a correlation. Any question? So write down the equation of the line that I wrote at the beginning. I want someone to read it off to me. So we said y equal to 90.19 plus 0.0067x. So please write that down. So I want to just go to graphing again and then graph that. So did we say 90 point, what was the number? 90.19
19.
plus 0.0067?
Yes.
X. Okay. Oops. No way. 90.12. 90 point, is that 12 we said?
19.
19 plus 0.0067x. Yes. So we put in the values and now we go to graph. So do you see this is the line of best fit? Still a lot of points away, but this is the line of best fit for this set of data, if that makes sense. So this calls the line of best fit. Here, line of best fit. That's the best, that's a line that the best fits these points. Okay, so I hope you got some view of what to do here. Let's do another one. Okay. So look at number 15. Let's do that. Can someone please read number 15 here? So for the plotting part, it's good to see. I mean, you need to do it for the examination, for the visual examination, and may show up on the homework or test. And then the same thing with the line. So I want you to know how to, not graphing the line much, but being able to write the equation and use the equation. So basically try to practice all the steps I showed you. Okay, so number 15. May I have a volunteer to read number 15? Just the question itself, the table we're going to observe all together. Pizza and Subway. Pizza and the Subway. If you're interested to read, you can either start reading or text me and I call your name to read.
I can read.
Okay, please go ahead.
Pizza and Subway. The pizza connection is the principle that the price of a slice of pizza in New York City is always about the same as the subway fare. Use the data listed below to determine whether there is a significant linear correlation between the cost of a slice of pizza and the subway fare.
Thank you. So as you look at the table, there are many datas, but you are just looking at pizza cost and subway fare. And let's see if there is a correlation between the two. So where do you start? Write no hypothesis, as there is no correlation. alternative hypothesis as there is a correlation. So you can note to yourself that this is no correlation and this is a correlation. So L1 and L2. So put pizza cuts, write down null hypothesis, alternative hypothesis. Put pizza cost and subway fare in L1 and L2. And then try to come up with P with R. So if there is any correlation, what is the P value? Is it supporting that there is correlation, or we do not support that there is a correlation? And then I want you to write equation of y hat equal to. So let's just get started. So I'm going to give you 5-6 minutes. You put it in L1, L2, send me your p-value. Let's start with that. Send me your p-value and R. Okay. Great job, animal. I don't have the answer yet. We'll go over that. So now, what did you, Shelby, get for the P? So send me P and R. So this would be in L1, L2. Null hypothesis. Alternative hypothesis. Rho equal to 0, no correlation. Rho not equal to 0, there is a correlation. A requirement is just a visual examination. So step 3 is finding the p-value. And R, and writing equation of the line. So if you get your p-value greater than 1, then that means you're missing some ending values, some ending e2 negative something. Okay, so I'm going to give you a few minutes. Tell me what you get for the p. You go to test, you go to linear regression. Great job. A lot of right answers are coming. Okay, send me what you have for p-values. Okay, now work on the graphing part. Go to graph. You don't need to activate on and off. That was a one-time deal. So let's just do it. I'll do it too at the same time. So I'm going to mute myself and enter the data in my calculator. But for graphing, just you need to go to Zoom and then go to number 9, Zoom stat. Okay, so I'll mute myself and start entering the data in my calculator. Okay, let's just do the visual examination here to make sure that it's checking and meeting the requirement. You go to Zoom. Number 9, it says Zoom stat. you go all the way down, zoom, stat. So this visual, it's having a linear pattern and it seems to be a very strong one. So let's go to stat and test it now. We go all the way down to linear t-test, L1, L2, not equality, calculate. So do you see 1.6619 and so forth, e to negative 7? So that means you go backward 7 places. So you're going to have 6 zeros here. So this is almost 0. It's definitely less than 5% or any other alpha they offer. So there is enough evidence. There is enough evidence to support that there is correlation between pizza slices and subway fare. Okay. Does that make sense? So DF, if you see it on your calculator, just its degree of freedom. You don't need to calculate it, but if you want to be familiar with the name. Okay, so writing equation of the line, it's y equal to a negative 0.011 plus b 1.01. I'm going to round to 3 decimal places, so that turns to be 1x. So in order to see the graph, so write the equation, make sure you be able to do that. And to graph it, you just go ahead and type it here. Negative 0.011 plus 1.011x. And then you go and graph it. And do you see this is the line of best fit? So that's pretty much all you need to know for this section. Homework of this section and 10.2 is also up and it's due tomorrow night. Okay, when you were on the stat, oops. Nope, you don't need critical values. If there were critical values at any part on the homework, skip them. I will consider the points for them. So that's why if you're above 90 on average, I give you 100 because there are some parts that I cannot eliminate, but other parts are important that I can eliminate the question as well. So I have to leave it there. Okay. So I'm not sure if, yeah, that's still there. So one more thing. When you had linear regression test, R is correlation coefficient, in this case is 99. R square is explained variation. So if they say what is the explained variation, means the square r, or just directly use r square here. Any questions? So I put 2 videos on 10.1 that you can also watch. So let's take a couple of minutes of break. So let me stop sharing. Let me pause the recording. There we go. Let's go to 9.2. Let's go to 9.2 modules. Sorry, 10.2 modules. Again, don't forget to submit chapter 9 and 8 worksheet. So not much of a new calculator command in this section. Regression. Okay. We had done it. It's just more of examples that we will do. In this section, we're gonna present methods for finding equations of a straight line that best fit the point. So we already did that in the last section of how to find the best fit. The best fitting line is called regression line. So we did that. Its equation is called the regression equation. So when we said y hat or the estimate equal to a plus bx, that's the best fitting straight line or regression line. Okay. So given a collection of paired sample data, the regression line is the straight line that best fits the scatter plot of the data. And that's this one. So I'm going to give you a minute. I want you to write down the terms that you see. Regression equation is y equal to, in our calculator, we said a plus bx. It's the same thing. So a plus bx, where x is explanatory variable or predictor variable or independent variable. Y hat is the response variable or dependent variable. And again, write a plus bx. So I'm going to give you a few seconds to copy it down. Find the equation of a regression line. Same thing, random sample. We got to visual examine to make sure it's a straight line. If there is any outliers, we're going to remove them. Okay. Our calculator will give us the line, so we don't really need to use the formulas. So let's just do an example from the textbook again. Before going to an example, I wanted to talk about bad model and good model when you're making a prediction. Bad model, if the regression equation does not to be appear useful for making prediction. Don't use the regression equation for making prediction. For bad model, the best predicted value is simply sample mean. So if you see that it's not a good pattern, if R is not a small, if P is not a small, that there is a correlation, so it's a bad model. If you see the points are scattered everywhere, so it's a bad model. Don't use the prediction. Just use the sample mean. Means X bar or Y bar. So if that's a bad model. Good model, use the regression equation for prediction only if the graph of regression line of a scatter plot confirms that regression line fits the point reasonably well. And that means if p-value is small, if you have a good prediction, if you have R that is close to 1, close to -1, then that's a good fit, and then you can use the line. If not, then use the sample mean. So we're going to do some examples with that. You already have the calculator command, so we're just going to use the examples. Correlation, use the regression equation for prediction only if correlation coefficient R indicates that there is a linear correlation. And then scope, use the regression line for prediction only if the data do not go much beyond the scope of available sample data. So that means, like, let's say you have data here and they ask you to predict something very far from the rest of data that they have given. So if it's too far from the rest of data, then your prediction might not be a good idea. Okay. So just test and see if it's a good model. Not good model, use the mean of y's. Okay, so now let's go to the textbook. I have the textbook open. So I want you to page to some of the exercises in 10.2. Okay. So let's do this example right here. So let's do number 6 first. So I want you to read number 6 and then think what would be a right answer here. We're gonna do it together. So I want you to read number 6 first. See what would you do to solve this one. I want you to think about it for a minute or two before I give out the answer, and then we'll do more problems. Okay, for number 6, first off, tell me, so this is a head width and weight were measured for 20 randomly selected bears. For 20 bears. And then some measurements are given. X bar, which X is the head width. Y bar, which is their weight. R, correlation coefficient. And P, that is showing it's significant or not, which in this case, P is very small. So tell me, for this linear regression, is there correlation or not? Given the R, given the p-value, is there any correlation between the head width and weights of bears? Yes correlation, no correlation in number 6. So please send me your answers. I want to know if you have an idea of having correlation or not. Do you see correlation here? Yes, no, for number 6. Send me your answers through chat. So please send them. I see some coming. Based on the p-value or R. So p-value, maybe p-value is even a better indicator, because with R you would say, oh, 0.8. Is it close to 1? Should I say it's close to 1? Should I not? But p-value should be a good indicator. P-value is small. So if you remember, null was no correlation, and then alternative was correlation. If P is small, we are supporting the alternative. So, great job in the law, there is a correlation. So p-values is small. P-values is small, so there is a correlation. If there is a correlation, so that means that prediction line is a good line. So let me open it here. Okay. So if p-value is small, it's a good prediction. So you would say good prediction. Or there is a correlation because p-values is small. So yes, correlation. Okay. So if it is a good prediction, then you can use the line of best fit. So y hat is equal to negative 212 plus 61.9x. So it's telling you find the best predicted y hat, the weight, given that the head width is 6.5. So you know that x is width, y is weight. They want to predict weight given that the x is 6.5. You just substitute x by 6.5. So negative 212 plus 61.9 times 6.5. So use your calculator and tell me what you get for y hat. If this was not a good prediction, we would say the best prediction would be a y bar. But in this case is a good prediction, so you substitute x here. So put that in your calculator and tell me what you get. Great job, Tammy. That's what I got too. 190.35. If you find a bear with the head width of 6.5 inches, his or her weight, its weight is probably 190.35 pounds. That's the prediction of such bear. So now let's do number 5. Read number 5. Tell me first if that's a good prediction. If look at the R, look at p-values, send me if a strong correlation. Yes correlation, no correlation. Just look at the p-value and tell me yes correlation or no correlation. The p-value is 0.051. And then yes correlation or no correlation. Okay, great job, Shelby. And as you're saying, you're sending your answers, tell me why you think is a correlation or why you think it's not correlation. Great job, Shelby. Okay, send me if there is a correlation or there is not a correlation here. Okay. More answers. Good correlation. So this is a way to know if you learned this lesson or not. So for number 5, is that a good correlation, or is it a correlation in that problem, or no? Given the p-value. Okay, I want all of you to respond to this question. If you don't know how to answer this question, say, I don't know how to answer to the question. So Andrew, when it's close to 0, there is R. When R is close to 0, there is no correlation. When P is a large value, is no correlation. So which one of the two you mean? So I want all of you to answer, I got the lesson. I don't know what I'm doing here. I need more instruction. There is a correlation, there is not a correlation. So say something that I know you learned or not. Good, Tammy. Windamala, that's right. I will go over the calculator steps one more time. Great job, John. Okay, Mazen, that's good. No correlation since R is low, but also P is large. Okay, great job. So thanks for responding. Yes, there is no correlation, as many of you said it. So no correlation because p-value is large, is greater than 5%. And R is a small. So small r, large P means no correlation. If no correlation, then this line is not gonna be working. It's not a good prediction. So even we found the prediction, it's not reliable because there is no correlation. So what we use, they say what would be the rating by male? A female is X equal to 8. So because you cannot really use the line of prediction, we said we use the sample mean to be our best Y prediction. So 5.9 is the answer to this question. You don't plug it in, you don't plug X for X here because it's not a good prediction. Okay, let's do one more. Go to the textbook. Let's go to the next page. Let's see if you have a set of data. Okay. So Old Faithful, let's do number 14. Or I think in L1 and L2, do we already have number 15? Let's see. What do we have in our L1 and L2 right now? Yeah, so let's do number 15 first. So about the pizza cost and subway fares, find the best predicted subway fare given that the cost of a slice of pizza is $3. Is the best predicted subway fare likely to be implemented? So go to your calculator, look at the p-value. So for those of you who wanted to repeat the process, so you put things in L1, L2, you go to stat, you go to line regression t-test. Is there a correlation or not? P-value is very small. So there is a correlation. So I may use the equation of the line. So y hat is equal to a, which is negative 0.011 to 3 decimal places, let's say, plus b 1.01. The more decimals you write, the better. So x, that's a good prediction. So we said it's a good prediction because p-values is small. So now they say that x is pizza, because that's what we put in for our L1, and then y is subway fare. So they say if the cost of pizza is $3, since it's a good prediction, you substitute it. Otherwise, you would have used sample mean for y. So now it's okay to substitute 3. Tell me what is going to be y hat. $3 and how many cents? Put it into your calculator. $3.02. Yes? Do you think we can, do you think a subway fare can be $3.02? Could that be $3.02? Or that's a very odd number to be? That's what I mean by can they implement it? What do you think? So they can't, because it's either should be $3 or $3.25. So just $3.02, it's not probably exactly what they're gonna use, because they would have used 3 or 3.25, not 3.02. Okay, so now with the other one, let's go to the other question. The one with the Old Faithful. So it says, how does it compare an actual eruption with the duration of 253, an interval after time of 83 minutes? How does that compare? Find the best predicted interval after time of eruption. So with this one, if you remember, we came up with the equation of a line. So we had y hat equal to 90.2 something plus, at the beginning when we put Old Faithful, 0.0067. But we said that there was no correlation. If you remember, we had a large p-value. We said no correlation. So if there is no correlation, then it's not a good, it's not good that we use this prediction line for our estimation. So we need to find the average of y values to be our best estimate. So when you are putting that in your calculator, as you scroll down, not for this problem actually. So let's just go and put that, the y values in your L1, since you know what you're doing, you want to find the average of y. The average of y is your best prediction. So if line is not a good prediction, then the average of what you have for y is the best prediction. So if you already had these things in your calculator, 242, let me put x, 255, 227, 251, 262, 207, 140. And then on the other line, you would have 91, 81, 91, 92, 102, 94, 94, and oh, what did I miss? 91, 81, 91, 92, 102, 94, yep, 91. Okay, so if you go to stat and you go to test and you go to line regression t-test, you would see that there is no correlation because p-value is very large. So if p-value is very large, then you don't use the line to predict. You go to stat, you go to calc, and you find the average of y, not average of x. Put it as L2 because you want to find the average of L2. That's about 92. So do you see the average here? That's about 92. That's the average. So the best prediction would be 92, and then that was in minutes. Okay. Any question? And it says, is that close to 83? I mean, it's 9 minutes away, so it's fairly close, but not very. So it's just write down your judgment there. Okay, any question? So if line is not a best fit, then you're gonna use L2 and you find the average of L2 or average of Y for sample, mean of the sample. Okay. If p-value is large, then we do not use the line for the prediction. We use y bar, we use average of y. So what I wanted you to do until the end of the class today, I want you to log into my math lab, open 10-2 assignment. So let me stop sharing here. Go to the 10-2 assignment. And let's get us started on doing some of them. So I'm gonna hold basically the lesson until 11 our time. And in the meantime, I want you to log into my math lab. Okay. Go to the assignments. And let's do some of the 10-2 homework. So it should be up. So tomorrow I'm going to teach chapter 11. So I want you to get us started. Have your pencil, paper, calculator. Some of these are so easy. It's just saying to select which one is a good model. So y hat is equal to something plus something times x. And then you fill it in. Slope of 120 and y-intercept of negative 373. Whatever goes first is the y-intercept. So negative 373. Slope is the one that is always multiplied by x, 125. So slope multiplies by x, and then the y-intercept. What does this symbol represents? That means the prediction. So this is just a symbol. So I want you to move on and then go forward. So I'm going to give you the remaining of the class to do them and ask me questions. So you could skip to other questions. You don't have to follow the pattern, like go to number 6. This is a good one. So keep doing it and ask me if you have any questions.